Hello everyone, I'm Siriji from Sri Venkateshwara College of Engineering, studying in 6th Sem, Department of Computer Science and Engineering. I'm here to discuss about the topic SIC Xe Machine Generate Object Program. Let us consider this example. Here we need to calculate location counter, object code and object program. Here the example is the name of the program and opcode start meaning it is the starting instruction and operand 4000 is the starting address which is being initialized in the location counter. And from LDS #3 to STI gamma X it is are purely not acting on register, so this instruction can be either format 3 or format 4. If any mnemonic symbol is preceded with plus, then it is format 4 or else it is format 3, for which we will be allocating 3 bytes in the location counter. By adding 3 bytes to 4000, we get 4003. And since it is in the format 3, again we'll add 3 bytes to it, we will get 4006. And by adding 3 bytes, we get 4009. And by adding 3 bytes, 400C. In the similar way, it is 400F, next 4012, and from add RSX to COMPRXT, it is of the register, so it is in the format 2, which we will be allocating 2 bytes. So by allocating 2 bytes to 4012, we get 4014. In the similar way, we get 4016 by allocating 2 bytes. JLT add loop is in the format 3, so we will be allocating 3 bytes. So 4016 plus 3 we get 4019. And RESW is the reserve word. Each word is of 3 bytes. So 100 into 3 is 300, which is of the decimal form, and when we convert into hexadecimal we get it as 12C. So 4019 plus 12C we get 4145. In the similar way, RESW is the reserve word, so 100 into 3 is 300, which is of the decimal form, and when we convert into hexadecimal we get 12C. So 4145 plus 12C we get 4271. In the similar way, 100 into 300 is 300, which is of the decimal form, and when we convert into hexadecimal we get it as 12C. So we add 4271 plus 12C, we get 4390. This is all about location counter. And next we have to calculate the object code. This is the object code format for format 3 and format 4. Opcode LDS. Opcode for LDS is given as 6C and value of 6 is 0110, and for C we'll consider only first 2 bits, that is 11. Since #3 is the immediate addressing mode for which n value will be 0 and I value will be 1 and x value will be 0 and e value will be 0 because it is of the format 3. Here #3, here the operand is the direct value which is #3, so no address for 3. 3 itself will be acting as displacement value, so B and P will be set to 0. And by grouping the first 4 bit we get the value as 6, and the next 4 bit, that is 1101, we get as the value D, and the next 4 000 we get as value 0, and the next 4 bits 000 we get 0, and again for the next 4 bits 0000 we get it as 0, and the last 4 bits, that is 0011, we get the value as 3. So the object code for LDS #3 is 600003. Opcode LDT value is given as 74. Value of 7 is 0111, and for 4 we consider only first 2 bit, that is 0 and 1. Since #300 is the immediate addressing mode for which n value will be 0 and I value will be 1 and x value will be 0 and E value will be 0 because it is of the format 3. Here the operand is of the direct value, which is hash 300, so no address for 300. It will be acting as displacement value, and 300 is in decimal form, so we should convert it into hexadecimal. We get it as 12C. The value of 1 is 10001, and value of 2 is 0010, and the value of C is 1100. So by grouping the first 4 bit, we get the value as 7, and the next 4 bit 0101 we get the value as 5, and the next 4 bit 0000 we get the value as 0, and the next 4 bit 0001 we get the value as 1, and the next 4 bit 0010 we get the value as 2, and the next 4 bit 1100 we get the value as C. Opcode for LDX is given as 04, and the value of 0 is 0000, and for 4 we'll consider only first 2 bit, that is 01, and since it is of the immediate addressing mode, N value will be 0 and I value will be 1. E value will be 0 because it is in the format 3, and 0 in the decimal as well as in the hexadecimal, the value will be the 0 itself. So it is 0000, and here also 0, and here also 0. By grouping the first 4 bit, we get the value as 0, and the next 4 bit 0101 we get the value as 5, and the next 4 bit is 0, and the next 4 bit is also 0, next is 0, and the next is 0. Opcode for LDA is given as 00. So by group 0000, and again first 2 bits we will consider, so it is 00. Since it is not in immediate addressing mode nor in indirect addressing mode, the value of N will be 1 and I value will be 1. Making use of X register, X value will be 1 and E value will be 0 because it is of the format 3. By making use of the formula, that is displacement is equal to operand address minus PC value, that is for alpha it is 4019 minus 400C, we get the value as 00D, and we'll write it in displacement, that is value of 0 is 0 and value of 0 is 0 and value of D is 1101, and by grouping first 4 bits we get the value as 0, and the next 4 bits 0011 we get it as 3, and 1010 we get the value as A, and the next 4 bits it is 0, and the next 4 bit is also 0, and last 4 bit 1101 we get the value as D. Opcode for add is 18, so the value of 1 is 0001 and value of 8 will consider only first 2 bit, that is 10. Since it is not in immediate addressing mode nor in indirect addressing mode, value of N will be 1 and I value will be 1. Making use of X register, so the X value will be 1 and E value will be 0 because it is of the format 3. So making use of the formula, value of beta is 4145 minus 400F, we get the value as 136 and we'll represent it in displacement, that is value of 1 is 0001 and value of 3 is 0011 and value of 6 is 0110. By grouping the first 4 bit we get the value as 1 and the next 4 bit 1011 we get it as value B, and the next 4 bit 1010 we get the value as A, and the next 4 bit it is the value 1 and the next 4 bit it is the value of 3 and last 4 bit 0110 we get the value as 6. Opcode for STA is given as 0C, so the value of 0 is 0 and the value of C will consider only first 2 bit, that is 11, Since it is not in immediate addressing mode nor in indirect addressing mode, value of n is 1 and I value will be 1. Making use of X register, the value of X will be 1 and E will be 0 because it is of the format 3. Making use of the formula, value of gamma is 4271 minus 4012, we get the value as 25F and we'll write it in displacement. So value of 2 is 0010 and value of 5 is 0101 and value of F is 1111. By grouping the first 4 bit 0, we get the value as 0 and the next 4 bit 1111, we get the value as F and the next 4 bit 1010, we get it as value A and the next 4 bit it is of the value 2 and the next 4 bit we get the value as 5 and the last 4 bit we get the value as F. Since add RSX and COMPRXT, this is the format for writing in the format 2, that is opcode, register X1 and register X2. Add value, opcode for add value is given as 90, so the value of 9 is 1001 and value of 0 is 0 and register value of S is 0100 and register value of X is 0001. And by grouping this, we get the value as 9041. Even COMPR is of the register format, so it is of the format 2. This is the format for writing the register in the format 2, that is opcode, register X1 and register X2. COMPR value is given as A0, so the value of A is 1010 and value of 0 is 0000. Register value of X is 0001 and register value of T is 0101. By grouping the first 4 bit, we get the value as A and the next 4 bit the value as 0 and the next 4 bit as 1 and the last 4 bit we get it as 5. For next 3 instruction, we don't need to generate any object code for the reserved words and we generated the object code for the different instruction in the program. And for JLT add loop, for JLT value is given as 38, value of 3 is 0011 and value of 8 will consider only first 2 bit, that is 10 and value of n and I will be set to 1 because it is not in immediate addressing mode nor in indirect addressing mode and E value will be set to 0 because it is of the format 3. So using the formula 4009 minus 4019, we'll get the value as FF0 and we'll write it in the displacement in 12 bits. By grouping the first 4 bit, we get the value as 3 and the next 4 bit 1011 we get the value as B and the next 4 bit 0010 we get the value as 2 and the next 4 bit 1111 we get the value as F. Similarly, the next 4 bit value is F and the last 4 bit we get the value as 0. The format for writing the object program is header record, text record and end record. In header record, column 1 is represented by H and column 2 to 7 it is program name and column 8 to 13 it is the starting address of object program in hexadecimal and column 14 to 19 it is length of the object program in bytes, that is hexadecimal. And next is the text record. In column 1 it is represented by T and column 2 to 7 starting address of object code in this record and column 8 to 9 length of the object code in this record in bytes and column 10 to 69 object code represented in hexadecimal, 2 column per byte of object code, end record column 1 E and column 2 to 7 it is the address of the first executable instruction in the object program. This is the object program for the given problem. As we discussed in the format for writing the object program, it is of the header record, text record and the end record. Header record in column 1 it is represented by H, and next 2 to 7 of the program name, that is EXAMPL, and the next 8 to 13, column 8 to 13, it is the starting address of the object program, that is 004000, and the next 14 to 19, it is the length of the object program, that is the last address minus the first address, we get the value as 000390. And coming to text record, column 1 is represented by T, and 2 to 7 it is the starting address of the object code and this record, that is 004000, and we'll calculate this later. And this is the object code from the starting, that is 6D0003 75012C, and next 050000, next 03A00D, and next 1BA136, and next 0F825F, next 9041, and next A015, and next 3B2FF0. It should not exceed 69 in the text record. If it exceeds 69, then we should start in the new line. The text record should be started in the new line. Since 2 column is equal to 1 byte, and when we start calculating from here to here, we get the 50 as the value, and when divided by 2 we get it as 25, and when we convert it into hexadecimal the value is 19. Coming to end record, column 1 is represented by E, and 2 to 7 it is the address of the first executable instruction in the object program. This is all about SIC XE machine generate object program. Thank you.